In this video, we'll be talking about the law of sines and how to solve a triangle that's not right. We spent a lot of time earlier in this semester solving a right triangle. Today, the triangles aren't going to be right triangles anymore. So what does that mean for us? It means that all of our SOHCAHTOA 30, 60, 90 stuff, square root of 2 over 2, 1/2 square root of 3 over 2, Pythagorean theorem, a squared plus b squared equals c squared, it's gone. All right? Can't use it anymore. Instead, we're going to be using this idea of law of sines. Now, assuming we get back in school, I fully intend on you guys using a note card. So this is where I distribute a new virtual note card to all of you. Hopefully you have one laying around somewhere. But the very first thing I'm putting on there is these ratios right here. Sine of angle A over A equals sine of angle B over B equals sine of angle C over C. And the reciprocal of this is true if you ever need it. You're going to see me write it like this top box more times than not. And so using this formula right here on top, I should be able to solve triangles that are not right triangles. I'm not going to say non-right triangles. Let's call them oblique triangles. The French call it oblique. We'll just call it oblique here in America, all right? Oblique triangles, triangles that are not right. And so the problem's going to look very similar to something that we did earlier this semester. I'm going to say solve the triangle. Except for SOHCAHTOA, it doesn't work. And so this first batch of triangles I'm going to be pushing out to you, they're just going to follow, you're going to be able to use the law of sines on it. And the way that I always start my law of sines is I always look for an angle in which a side across from it is given, okay? This angle being, or this side being little b because it's across from angle b. And that's how I start my law of sines. I can take sine of that 20 degrees and I put it over the side across from it. Now you can actually use this law of sines to solve for angles or to solve for sides, whichever one you want to do. Okay, whichever one you need. Okay, the only other angle I am given is this 45-degree angle, and it will tell me what the side is. If I plug this into the law of sines, it'll tell me what the side is across from this 45-degree angle, and so that's what I want to do. So I won't ever be using all three of the law of sines, A, B, and C. I'm just going to be using two at a time, whichever one strikes my fancy that I can use to solve. Now, even though that says sine of 45 degrees, we are plugging it into our calculators, all right? And so, plugging this in the calculator, first order of business is get that calculator out of radians for this week. We're going to be in degrees all week. I don't remember seeing anything in radians as far as this goes. And it normally isn't in most pre-calc books, okay? And so all I want to do is solve this for C. Now, this is where a lot of you will say, oh, sweet, I can cross multiply. Oh. No? If there was such thing as cross multiply, yeah, I guess it would work. I could do C times that sine of 20 degrees, and then I could cross it the other way. What color am I on? Green. I could do is equal to 10 times sine of 45 degrees. But I assure you, that's not what I did there, all right? I actually just took both sides of this equation and I just multiplied it by my least common denominator here, 10c. And so whenever I multiplied this by 10c and this by 10c, it gave me this line underneath, all right? So in no way, shape, or form am I admitting to cross multiplication here. But you can kind of see where I need to go from here. I'm just wanting to solve this for C. And so the opposite of multiplying by sine of 20 degrees is dividing by sine of 20 degrees. And whatever I do on one side, got to do on the other. And that will break all the way down to give me what my C is equal to. So in degrees, I'm going to hit 10 times sine of 45. I know 45 is a nice angle, but we're going to divide it by sine of 20, and it's going to get nasty anyway. Plugged all that in my calculator, and we'll do one decimal place on these. 20.7 is what I got. So that's my C right here, is 20.7. Good. Okay, now, I would argue the easiest thing to find on this would be angle A, and it probably should have been the first thing I found. Because to find angle A, I still have 180 degrees in a triangle. And so if I have a triangle sum theorem says there's 180 degrees in a triangle. And if I ate up 20 degrees and 45 degrees down here at the bottom, then it tells me what I'm left with for angle A. 180 minus 20 minus 45 gives me 115 degrees. So I'm good there, right? And so I actually found out what this is. 115 degrees. Now, it was imperative for me to find that because I still have to find side A down here. And in order to find side A, I'm really running low on colors here. Let's see. Let's do this one. I can set it up using the same way. Now, I think it's going to be safe. Safety Steve is going to tell me to use this sine of 20 over 10 because that was the two values they gave me to start with. All right, it's that way that the answer to this one isn't dependent on my previous answer. Right. And I just set this up using law of sines again, so I can take sine of that 115 degrees, and I'm going to put it over this A down here that I'm looking for. And so as you can see, I have the exact same math. I get to multiply both sides by 10a this time, which makes it look a lot like cross multiplication. But I assure you, I have never cross multiplied in my life. It's probably not true, but I can make it believe it. I do the exact same math, starting to run in my triangle there. It's all right. And I get a is equal to, and notice I'm just typing everything in my calculator at the end. That way I do not get a rounded answer of a rounded answer of a rounded answer and just keeps going. Okay, so I'm just going to hit 10 times sine of 115 and then divide that by sine of 20. We'll do 26.5 on that is what I got. We have answers flying all over the place on this, all right? And so I need you to do me a favor. I need you to either circle or box in the three answers that you need me to know, or you can just draw a triangle like I did down here and label everything. So either way, I just need to be able to find your answers on your sheet rather quickly. Let's go again. Yeah, now, looking at this triangle, I'm thinking this one's going to be just a tad bit harder because I am not given an angle and a side across from it. I don't know what's across from this 82 degrees. I don't know what's across from the 24 degrees, and I don't know the angle across from this side CB right here that's 11 units long. But again, this guy's going to be the easiest to find. Okay? My angle A, using the triangle sum theorem, is just going to be whatever's left from 82 degrees and 24 degrees. Okay? And so, just to make sure my video is right, I'm going to try to limit the mental math on this the best I can. I got 74 degrees on there. Boom, box that in. Put the degree symbol, remember, if you don't put that degree symbol, I'm going to assume radians, and that is a ton of radians. But now I have 74 degrees. Now I have my template in order to find my other two sides. I can simply use the sine of this 74 degrees over 11 and set it equal to, I'm just going to find the bigger one first. It doesn't really matter which one I find. Law of sines doesn't lie on these. We're calling this side C because it's across from angle C. Okay. So I'm going to let you guys work that one out, solve for C, and then see if you match my answer. Hit pause on the video, by the way. On that one, I hope you got 11.3. If not, there's where there's the math I did for it. All right, I want you to, so we got C is 11.3. That's down here. I want you to go ahead and set up and find side B. All right, so hit pause on the video again, and then set it up, solve it, and we'll come back and see if we match answers. B equals 7.4. Oh, just kidding, 4.7. Oh, my bad. All my answers are equally circled. My math teacher can easily find them. I feel good about that problem. That's really it for this video. I was going to make up a problem, but I think that we're probably going to be good on this. So I want to jump ahead and talk about some word problems that we might see on the practice set and on the quiz coming up. All right, it looks like the Goodyear blimp here. All right, it says a diagram. The diagram shown in figure whatever this is represents the height of a blimp flying over a football stadium. Find the height of the blimp if the angle of elevation at the southern end zone, point A, is 70 degrees. They've got that labeled for us. And the angle of elevation from the northern end zone, point B, is 62 degrees. I want to find the distance between the viewing points of the two. Find the distance between the viewing points of the two end zones is 145 degrees. I want to find the height of the blimp. All right, finding the height of the blimp. So, first step on this is I'm going to need one of these sides. This is going to be kind of weird. I'm not going to draw the height on here yet, but obviously I'm going to have to use a law of sine somewhere. Okay, and so I'm going to go ahead and use my triangle sum theorem and find that angle up there next to the blimp, because like the last example, I'm not really given any angle in a side across from it. So I found it to be 48 degrees. Okay. Now I'm just going to pick a side. All right, I'm just going to find what I'm going to call this little b right here. All right, I'm going to find out what that little b is. And so I have it set up where my sine of my 48 degrees over 145 yards, keep in mind that's my unit for measurement when we get to the end, is going to be equal to sine of 62 degrees over b. By now you can probably solve this about as quick as I can. And then from here, I am going to divide both sides by sine of 48 degrees. So I got 145 times sine of 62 divided by sine of 48. 172, well, let's do one decimal place again, 172.3. And that's yards. So that is how far it is from that end zone up to the blimp, that diagonal distance. Okay. All right. Only way I can think to solve this is bring SOHCAHTOA back in, because the height, it says find the height of the blimp. It took me a while to find what I was actually looking for a while ago. I'm wanting to know the height of the blimp. Whenever I measure the height, it's just going to be the height of this triangle that comes down and forms this right angle. Huh. Well, that means that this 172.3 I found is actually my hypotenuse across from that right angle. And what I'm looking for is the height, h right here. So I got to dig way back in my back pocket, what we call last week, of which trig function am I using. If I know that this angle is 70 degrees, I'm wanting the opposite, and I know the hypotenuse. Well, it has to be sine. Sine of that 70-degree angle is going to equal the opposite, which I unfortunately labeled as h because I was saying height. And then the hypotenuse that we just found, 172.3. And so to find out what h is, I'm simply going to multiply both sides by 172.3. I get sine of 70 times, 172.3. and that gives me 161.9 yards. And that would be the height of the Goodyear blimp on this problem. Don't worry if you would have said, well, man, I would have used that 62 degrees and messed everything up. You still would have got the same answer. Okay? You know, the way that all this works, it does turn out to be the same. Right, I'm going to give you a second, and then I'm going to have you try to draw your own picture on this. Remember, we're going to have oblique triangles, and so pause the video, you draw your picture, I'll draw my picture, and we'll see if they look similar. Okay, this is what I've come up with so far. All right. I'm not going to draw two students, and hopefully that you notice looking at this drawing why I'm not your art teacher. This is something you can definitely find on a second grade student's art project or paper or whatever they're doing. Okay, so man, not enough information given. It almost looks like I could use a SOHCAHTOA just over here on this small rectangle. It's not rectangle. I just did a calculus video. Triangle, but I'm not giving any sides of it. Ooh, all right. So, best way I can think to solve this is that this right here forms a linear pair. Linear pair postulate says that should equal 130 degrees then. Well, dialing back to my geometry days, there's 180 degrees in a triangle. And so, just looking at this, I'm going to call this the red triangle over here. On the side, I can get that measure of the top of that red triangle, that oblique triangle. Just 180 minus 39 minus 130. Yeah, that's what I thought it was going to be. 11 degrees. Really small. Must be a tall building. All right, now I have that elusive 300 and the angle across from it. Okay, so I can do the sine of 11 degrees over 300. How did I know to do this? Well, I'm just finding stuff, all right? I'm just getting as much information out there as I can until something clicks. I'm not going to say this is the only way to work it, but this is just what's making sense to me as I just put in more and more information on this. All right, so I guess it would be fine to either find this side or this side, whichever one you wanted to do. I think I'm just going to find this one since it's closer to the building right here. Okay, so I'm going to do sine of that 39-degree angle. And let's make up a variable here. Let's call it hypotenuse by 38. So let's just call it x. Let's erase this other x because that looks very x right there. Okay. So oops, I put my 300 on the wrong side. We'll fix it. Let's do 300 times sine of 39 degrees divided by sine of 11. So that's 989.5 feet. Write that down. 989.5 feet. It's something different. Let me know during the Q&A or post a comment on this video and tell me. Okay. So now I'm going to go over to this blue triangle. I know what that x is right there. I can go back to my SOHCAHTOA days just like I did on the blimp problem, where I can just take sine of 50 degrees. And again, I'm using sine because I'm looking for what's opposite the height of the building divided by the hypotenuse we just found was 989.5. Now, I want to say, if we would have found this check mark instead, it all still would have worked the same. I would have just found the big red triangle now and used 39 degrees here instead of the 50 degrees. So it all works out. Definitely more than one way to solve these problems. So I get sine of my 50-degree angle Multiply that by 989.5. And that was like right at 758. A 758 foot tall building. I could see that, yeah. So that would be my final answer. And don't make me believe that's your answer. That's just helped me get to the final stuff. So box in those final answers. Here's 5 problems. If you have problems over these 5 problems, it looks like 2 are just basic law of signs right here, and then the last 3 will be word problems. Definitely want to hash these out during our Q&A if we're having difficulties with